card 11, we're going to talk about continuity. Number 1 says a function is continuous at all x values. Continuous at all x values if there are no breaks in the graph. Number 2 says a function is continuous at a point if the graph does not come apart at that point. And number 3 says a function is discontinuous if a break occurs in the graph. Okay? This can be a fairly easy topic as well. Looking at the first example here, this graph is continuous at all x values because all we see is from the left to the right a continuous smooth curve, no breaks, no holes. It's continuous at all x values. Then we could have a removable discontinuity. I'm going to talk a little bit about this, but we'll be talking more about this at a later date. It says if a point can be put back into the hole in the graph and the graph becomes continuous, then the function has a removable discontinuity at that point. Looking at this first example, if we start from the left and we start to come around to the right, we see there's a hole here. But because up here that hole is back here, we can replace this point back into the graph, making this graph have a removable discontinuity. And I'll discuss this graph later. We could also have a jump discontinuity. And a jump discontinuity, it says there is more than just a hole in the graph. There is a jump in the graph at that function. And so what we have here from the left, we come up, and it just doesn't have a hole, but the graph actually jumps, and so there's this gap through here, and then it continues on. So that's called a jump discontinuity. You are going to need to know what that is. Basically, on an assignment, maybe a quiz or a test, I may give you some graphs like these and ask you to tell me, is the graph continuous? And if not, what type of discontinuity does it have? And then finally, the last graph, we have an infinite discontinuity, and it says there is a break in the function. And what we have here, if we're going from or coming from the left, then it goes down to negative infinity, it looks like. And then over here it picks up from positive infinity, looks like. But there's this gap here. And what we'll be talking about this year, you may have never heard of an asymptote. And what we would actually have here is one of those, which is basically, this is a vertical asymptote. It's an invisible vertical line that this function will never touch. And so because this exists here, we obviously have a break. You should be able to see there's definitely a break. There's some discontinuity in this function from this side to this side. But it's different from the jump discontinuity and any other form of discontinuity because of the fact that the functions go in opposite directions. This one's going down, this one's going up. It will never touch this invisible vertical line. So this is an infinite discontinuity. At this point, for right now, all we're going to need to be able to do is look at specific graphs and tell if it's continuous, or if there is a type of discontinuity, what that type is.